As we know, the electronic configuration of carbon is 1s2, 2s2, 2p2. This is also known as the ground state. When it is prepared for bonding, one of the electrons from the 2s orbital is transferred to the 2p orbital, which is possible since 2s and 2p has similar energy level. This is when it gets to its excited state. The electronic configuration would be 1s2, 2s1, 2p3. The shape of the s orbitals are spheres, while the p orbitals are dumbbell shapes. One s orbital will be hybridized with 3 p orbitals to form sp3 orbitals. So we have 4 sp3 orbitals. The 4 sp3 orbitals of carbon bonds with the s orbital of hydrogen, resulting in this diagram. Since the orbitals are directly overlapping, this is called a sigma bond. Hence, we have 4 sigma bonds.
For C2H4, each carbon are required to form 3 bonds, so 1 s and only 2 p orbitals are needed. The 2 p orbitals hybridize with the s orbital, forming 3 sp2 orbitals, and the other one remains unhybridized in the form of a p orbital, which has the shape of a dumbbell. Here is C2H4 in the form of a diagram. The s orbital of hydrogen bonds with the sp2 orbitals of carbon. Since it is directly overlapping, it is called sigma bonds. However, the carbon-to-carbon bond with p orbital will hybridize. Since it is a sideways overlap, it forms pi bonds. For C2H2, only one p orbital hybridizes with the s orbital, forming 2 sp orbitals. The 2 other p orbitals of carbon remain unhybridized. Here's what it looks like in its diagram. The s orbital of the 2 hydrogen atoms bond with the sp orbital of the 2 carbon atoms. Since they are directly overlapping, the bonds they form are called sigma bonds. The carbon atoms are joined together by 2 sp orbitals directly overlapping each other, so they are also sigma bonds. Finally, there are 2 p orbitals sideways overlapping, forming 2 pi bonds.